could have had like one parent that was Jewish or somewhere farther down the line.
Okay, everyone. I've got some things to discuss with you all before we hop into today's material. Namely, I think that we kind of got off on the wrong foot here a little bit. So we're going to restructure some things a little bit, hopefully to make your lives easier, not more difficult. Starting with the studios. Those have been a bit more challenging than I think any of us anticipated. The setup stuff, there's no way we could have predicted that, how many problems we were going to have with the setup stuff that we ran into last week and the week before that, honestly, as well. What we've decided to do is make studios just graded based on attendance, basically. So if you show up, you participate, you don't slack off during the studio session, you'll get credit for that particular studio. However, we still really want to encourage you to actually finish the studios, not just show up and work on them for 90 minutes. So with that being said, we are going to allow you to demo studio twice. Once for if you just show up, you'll get credit for the studio. You can get the maximum credit in the course if all you do is show up and participate. If you complete the studios and you demo the completed studio to us, then we will give you a little bonus credit on top. So not a lot. If you demo every single studio in the class, you'll probably end up with maybe 2 or 3% extra on your final grade. So it's not huge, right? But it's a little something to encourage you to actually complete the studios. Also, I think that we did not get off on the right foot in terms of maybe the pace of the class the last couple weeks. I feel like we've been a little fast in some respects and a little uneven in other respects, I suppose. So what we've decided to do this week, I talked to my TAs about it, and we're going to hit the pause button. Today, I was going to talk about web APIs and asynchronous programming. I'm not going to talk about that today. I've pushed that off to next week. What I'm going to talk about today instead is just do a really in-depth, as much as I can, overview of the architecture of an Android app from top to bottom, just to make sure that we all are on the same page. I know some of you may have already seen this, may already understand it. From the surveys that I read, there are quite a few people who don't, so I really want to make sure that that's solidified for everybody before we move on. And then on Thursday, what's going to happen is Taylor, one of the TAs for the class, is going to go over the studios. So at least the studio from last week, and he might do some stuff in the studio from the first week as well. That's what we're doing Thursday, yeah. So there is no new studio on Thursday. We're going to go over the previous studios on Thursday. Again, this is sort of an attempt to make up for what it's our fault. Honestly, I'm not going to try to sugarcoat it. I did not execute the way as well as I wish that I would have. So I'm sorry about that. It's a new class. We're still figuring things out. I knew we were going to screw some stuff up. I didn't think it was going to happen this soon, but you know, it did. And I think it would be wrong to pretend like everything was going smoothly, because it wasn't. It was not going smoothly. There were some problems. So I want to address those problems now, get things back on track sooner rather than later. And I think this is the right way to do it. So does anybody have any other questions, comments, other things about that kind of stuff? Yeah, in the back.
We're just going to demo our studios and so want to get our pages here.
If you're just going to do it for the attendance portion, then not necessarily, no. If you're doing it for completion, then yes, I do want you to commit. Yes? Yeah, there'll be some leeway for attendance purposes. And also, too, actually, I forgot to mention that we have no way of knowing who attended the first 2 studios. So as far as we're concerned, everybody attended the first 2 studios. So if you weren't here last week or whatever, you're getting credit for the attendance portion of the studio anyway, and if you want to submit it for completion, you are still welcome to do so. Yes.
So if like for a future studio we weren't here on the attendance day, but we still completed it, did we still get full credit for the studio, or is it more big?
That's a good question. I had not thought about that. I'll be honest with you. Give me a day to think about it, and I'll let you know on Thursday. Yeah, that's a good question. I've been trying to keep the website up to date as well with these changes that I discussed with you. So the calendar is up to date. I'll be honest with you. I expect the calendar to change again at some point in the future, but for now, it is up to date with what we just talked about. And I also updated the policies, specifically the section on studios, to indicate that if you demo completed studios, you can get a little bit extra credit, and otherwise you're just expected to show up and participate on studio days. Any other questions? Is anybody like really pissed that I'm doing this and unhappy? If you are, if you don't feel comfortable talking to about it in front of the whole class, come talk to me about it after class. Come talk to me about it in office hours. I want to hear your feedback. Your feedback actually is goes a long way towards why we are doing this, right? And so I want to thank you again for filling out those surveys. And for those of you who haven't been filling out the surveys, you really should fill out the surveys, because it helps us out so much to understand where you all are, so that we can make changes like this. If we hadn't done those surveys, I probably would have known that something was a little bit wrong, but not to the extent that I know now. So thank you very much for filling those out. Yeah.
Did you cut anything from the course in making these changes, or give us less time on the final project or something? Or?
I do have some candidates for things that may be cut in the future. But as far as the calendar goes right now, I did steal a little bit of time from the final project for this so far. But we may get that time back. I kind of want to see how the rest of the semester progresses. We'll see how it goes. Things are very flexible, as you can tell, which is a good thing. At least I hope you think it's a good thing, because it allows us to make these changes to hopefully make the course a better experience for you. Any other questions? Yeah.
How to demo studio? Is there a web page or just?
You gotta find us. You gotta find me. You gotta find the TAs. So we're here in class. You can do it on Thursdays when we do the studio days, or you can come to our office hours, which are on the website. Gotta come to one of us. Yep.
So when we demo the so we're demoing the studio for attendance before we leave class?
On Thursdays, yes.
Okay. And so is it okay if like our thing isn't working? So
yeah.
Our demo is like, here's the code I wrote.
Yeah, as long as you show up and you don't screw around for an hour and a half and you actually work for an hour and a half. Yep, that's what we're looking for. Yep. Any other questions? Any other questions? If you have any other questions, if you have any other concerns, please come talk to me. I want to make this course a good experience for you all. I'm not perfect. I'm going to continue to make mistakes. Just let me know how I can help you all, so that we can keep things moving smoothly. All right, cool. Let's talk about some Android stuff then, now that we got all that out of the way. I really want to focus all of the time today on just the various pieces of an app and how they all work together, because there's kind of a lot. I think you guys have already seen this, noticed this from working on the previous class examples in the studios. There's a lot of stuff going on in these apps, and it's not always 100% clear what part of the app is responsible for, what piece of behavior or whatever. So I want to go through, clearly break down the different parts and explain what they're used for. Some of this is going to be review, but towards the end, there's going to be new stuff. So it's not all review today. There is going to be some new content introduced towards the end of class today. And I wrote an app to help us understand the architecture as well. In fact, let me show you the app first. It's a little trivia app, nothing too special, right? You start up the app, and this is the screen that you get. I can request a particular number of questions, so type in a number like 10. I can select a category from this drop down here. So you see the various categories. So Oh, anime. I would be terrible at that one. Some of you might be good, I don't know. Video games. All right, something that I know. And then we hit the button and it comes back with, well, did I screw it up already? Is that category busted? Or am I on the internet? Because this does need the internet. What happened? What did I do? Oh, cool. Now it crashed. Awesome. Well, that was a good demo. Let me try it again. Maybe 10 questions. We'll just stick with general knowledge this time. And okay, yeah, it worked this time. I don't know what was up last time. Maybe I picked a bad category or something. And then it displays a list of 10 trivia questions, and then they're multiple choice, so it gives you some options for what the answers should be, right?
You're pulling this from some API.
I am. I'm pulling it from an API online, which is actually not what I want to talk to you about today. That's next week's topic now. We will talk about web APIs, how to fetch data from web APIs next week. That is included as part of this app. We're going to use this app to do that, but that's not what I'm going to talk to you about today. Today, instead, I'm going to ignore the web part of things and just focus on the general structure of the app. And this is all it does, by the way. That's it. It doesn't even check the answers to make sure it's correct. It just pulls the questions and the answers, the possible answers. Okay, so let's then start at the beginning with the different pieces of our app. First thing that we should talk about is the manifest. The manifest talks about essential information for your application. So things like, what's the name of your app? Duh, that's pretty essential. What are the various activities that your app contains? So we talked a little bit about activities a couple weeks back, or actually last week, as a matter of fact. Activities, I use an email app as an example. Could be browsing your inbox, that's an activity, right? Could be writing an email, that's an activity. So one app can have many activities. You can think of every activity, though, as a potential entry point into your app. That's sort of a good way of deciding whether something should qualify as an activity or not. Is this a potential entry point into my app? So a lot of apps are going to have multiple ways of entering. Some apps may just have one entry point, which is fine as well. The manifest is also going to specify what permissions are required. So do I need to have permission to access the internet? Does this app require permission to access the file system? Right? I'm sure you guys have seen this before. When you go onto the App Store, you download an app. What does it do? It says, you need to give me permission to this, 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 and the keys to your car and your social security number, right? Everything. It tells you exactly what permissions that app needs. That's all from the manifest. That's where that information is. Question?
So not to derail, but so recently Google's been doing a thing where it doesn't ask you for permissions to take photos until you open the camera part of the app.
Oh, interesting.
Okay, I was going to ask if that's seamless or if it takes a lot of work.
Is that, how recent is that? How recent are we talking?
Just this year, it's been a while.
Oh, okay. I actually am not familiar. I didn't notice. I guess I don't use camera apps a lot. I didn't notice that they did that. It's an interesting change. Oh, really? I would think that it's still going to be listed in the manifest, right? That you need permission to access the camera. So I suppose the difference there is that they're waiting until runtime instead of download time to show you those permissions. So not all permissions are created equal, I guess. Some of them are important enough to do up front, others not so much. Or maybe both, I don't know. And then required hardware and software too. So maybe it sounds silly, but some phones don't have cameras, right? So if your app needs a camera, you're gonna list that as a requirement for your app to function, right? You have to have a camera to use this thing. That's also gonna show up in the manifest. The manifest is all written in XML. So XML is, I know I kind of glossed over XML, which is part of the reason why I wanted to double back and talk about some of this stuff. XML looks a lot like another language. I hesitate to call it a language, but looks a lot like HTML, doesn't it? With the angle brackets. So this is the name of the tag, uses permission, and then anything that's inside of this tag after the first word is going to be an attribute of the tag. Just provides more context about what that tag needs to perform its job. So for this app, you can actually see it's got a fair number of permissions, and a lot of the, whoops, there's a duplicate there. I don't need that twice. A lot of these have to do with the internet, have to access the Wi-Fi, have to access the internet. Because it does, it needs to go online to pull data. Up until this point, we actually haven't needed to worry about permissions too much. And so then down here, you can see is the application section of the manifest that explains what the icon should be, what the app name should be, and then the various activities that exist in the app. So that's what's in the manifest. When are you going to need to change this? The biggest reason that you're going to need to change this is what we've been talking about, for permissions. That's really the biggest time that you're going to need to change the manifest. You might also need to change it if you add another activity to your app, but Android Studio does that for you, so you don't need to write that code. Android Studio is going to do it on your behalf most of the time. So we can leave the manifest alone for the most part, but it's still good to understand what it is and what it's telling us. Another big part of our app, at least, well, it's not actually directly part of our app, I guess, but it's still a very important part of how we're building things in this class, is Gradle, which I know has been a big source of confusion. So let's nail down Gradle once and for all. It's a build manager, which means a lot of things. What it does is it tracks everything that your app needs to function. So any external libraries that you need, yeah.
Just a quick question. So I'm assuming XML is the same, the differences between Java and Kotlin, or is there any?
XML is independent of Java or Kotlin. XML is used for all kinds of things. Actually, Microsoft loves using XML for things. When you save like a Word document, for example, if you open up under the hood, it's XML under there. So XML, I actually forget what the X stands for, maybe extensible or something like that. But the ML stands for markup language. And that's actually what the ML in HTML stands for as well, hypertext markup language. So it's not often a language that you use to write programs, it's a language that you use to describe information, right? It's a markup language, so you use it to describe information. And that's what we're using it for here. Great question. So Gradle is a build manager. Basically, what that means is anything that your app needs to function, I'm going to tell Gradle about it. And what that does for us then is it allows Gradle to make sure that we always have the most up-to-date version of those dependencies. So for example, there's some libraries that are very commonly used. If we have time today, I might get to something called a recycler view. I have it listed at the very end of today's class. If we have time today, I might get to that. In order to use it, I have to include that as part of my Gradle build, because it doesn't come with an Android app by default. It's not a piece of code that's in your app automatically. It has to be added if I want to use it. So I put that into Gradle, and then Gradle goes and finds that library and downloads it for me. And if Google or whoever maintains that library releases a new version of it tomorrow, Gradle will detect that that new version has come out and download the newest version so that I can use the newest stuff in my app if I want to. It takes a while. We've definitely noticed that. Gradle takes a while to function because it's building your app, which means not just compiling your code, but all of the library code and making sure that it's all connected together as well. Sometimes it means downloading stuff, which takes a while as well. So there's two levels to pay attention to with Gradle, the project level and the app level. For our purposes, the project level and the app level are not quite, but very nearly the same. I only have one app in here in this project. I theoretically could have multiple apps in this project, but I don't. I just have the one. So if I change the project level stuff, it affects all of the apps in my application, in my project, sorry. Right? Whereas every app is also going to have its own app level Gradle file that just targets that app, which is what we're going to use for most of the projects in this class, I would imagine. And so if you open one of these up, you can see dependencies. These are the things that my app needs to function. So what do we need? We need Kotlin, because we're using Kotlin, right? Constraint layout is a particular kind of layout that I've used in many apps this semester. So how do I use a constraint layout? Well, I need to get the constraint layout library from Android. I include it in my Gradle file, and then Gradle downloads it for me and makes sure that it's available for me. So I'm not going to go through all of these, but these are all various libraries that this app is using. Any questions about Gradle? Yes.
So I had a lot of trouble with Gradle earlier, so I want to make sure I understand everything about it.
Okay.
Do we ever edit it ourselves, or is it?
You might edit it yourself, yes. If you use, if you want to use something in your app that comes from a third party, right? It's not code that you wrote. It's code that somebody else wrote on a library somewhere floating around. I would need to add that library to my list of dependencies so that Gradle can grab it for me, and then I can use it in my app. It's not always easy to know when you're leaving the realm of Android standard library and third-party library, though, right? There's not a big red flag that says, hey, you're using third-party stuff. What you're going to see is that you try to use something and it just doesn't work. Android Studio says, I don't know what you're talking about. I don't know what this thing is, right? And so that's usually an indication to you that, oh, okay, this is probably part of some third-party library that I need to add to my Gradle file so that I can have that accessible to me. Great question. Any other questions? So Gradle does take a while. Building the apps do take a while. There's not much we can do about that except get a better computer. I mean, I don't know. There's really not much we can do about that. But think about what it offers to us. The old way of having to do this would be to literally go out and Google the library that I want, download it, make sure that it's in the right place, and then make sure that I knew how to manually compile my app that includes all of the libraries, right? That's how people used to do things all the time, and it's a real pain in the butt. This makes it easier. This makes our life easier. Okay. So let's take a look then at a typical structure of an Android app. I may have already asked about this in a previous class, I don't remember, but are any of you familiar with model view controller paradigm? I think it's, no? Okay, that's fine. Well, that'll make this easier then. For those of you, I mean, since it seems like most of you aren't aware of model view controller, it's a very common programming paradigm with distinct parts for creating apps. That's what iPhone uses. It's not used just with iPhone apps, though. It's also used with web apps very commonly. So if any of you took 330, I think it is, they might talk about MVC in there. I don't actually know if they do or not. Regardless, Android does something a little bit different. It's not model view controller. It's model view model is a very common way of specifying the architecture of an Android app. So what I want to do next is go through those three components: model, view model, describe what they are, right? Which files in my app correspond to those three categories, right? And how do they interact with each other? Because I think it's very important for understanding how our app's going to behave. We've talked about one of those three things already in pretty extensive detail. That's what we did last week, which is actually the view. So basically everything that we did last week, almost all of it, falls under the umbrella of the view. The view is the user interface, right? It's what the users see. So we see up at the very top, in our apps, the view is represented by activities and fragments. Activities and fragments are part of the view layer of our app. And so this is where it's kind of a review of what we talked about last week, but that's That's okay. Let's solidify these points and we'll move on to the other pieces, which is going to be new stuff in just a bit. So what really comprises the view? We have activities and fragments, but that's actually not all. We also have our resources are going to be a big part of our views as well. So resources being things like the various layouts, which are also written in XML, right? They're also written in XML. I can have constants. I can have things that are drawable. So if I want to have images or other kinds of graphics in my app, those all fall under the category of resources. The activities and fragments then describe the behavior of the user interface. What happens when I click on this button, right? What's the behavior that occurs when I click on that button? How do I get from one part of the app to another? That's the code that goes into the activities and the fragments. The look and feel, what actual components are on the screen, right? That's going to be my resources. And they have to work together. And so we've seen that, and I can show you how that works in this particular app. Down here, I see this folder, RES, for resources. We'll start using more and more resources as time goes on. For right now, the only resources that we've really been using are layouts. And those are the most important ones as well, in my opinion. And so, what is a layout? If I take a look at, actually, I don't want to take a look at that layout. Let me take a look at this layout instead. If I take a look at a layout, right, it's comprised of, actually, this is where the terminology gets a little bit confusing. It's comprised of views, actually. The term view in Android, in the Android app ecosystem, actually refers to any UI component. Any UI component. So that button is actually a view. That edit text is a view. There's a drop-down menu in here that's a view. All of those are put together to make a layout. And so I have various ways of laying things out. What I've chosen to use is called a constraint layout. It works by positioning the elements relative to other elements. That's why you see these arrows, these lines connecting the various elements. I'm not specifying an absolute positioning of the button. I'm saying that the button should occur 96 pixels below the drop-down menu.
Would this layout look good in all devices, different sizes automatically with constraint layout?
The idea, honestly, is that any layout you design should be relatively compatible across different devices. Now, when things start to get hairy, when you start need to put a little more thought into things, is when you change form factors. So if I go from a phone to a tablet, that requires a little bit more effort. But if I'm going from one kind of a phone to another kind of a phone, for the most part, you don't need to worry about designing different layouts in that situation. There are ways to screw it up, of course. There are ways to screw up anything. But for the most part, you don't need to worry about it. So the constraint layout is actually a special kind of layout. It was designed to be used specifically with this layout designer, with the drag and drop layout designer. It was designed specifically for that. Before this fancy drag and drop designer came out, we had to do everything in text with XML again, right? And so if we take a look at the XML, we can still see the structure of this particular layout. Notice it starts with the constraint layout up top, and then the spinner is the name for the dropdown. I've got the edit text. That's the text box. And then the button. Notice that the order that they appear in the file is actually not the same order that they appear on the screen, right? The edit text is actually at the top. But that's kind of where the constraint layout comes into play. Layout constraint, bottom to top of category spinner, right? It's saying that the bottom of this should be oriented towards the top of the combo box, meaning that the edit text is going to be above the combo box. It's always going to be above it relatively. That's what this option is saying. And if I look at the spinner, you can see top to bottom of, right? Number of questions is the ID of my text box. So this is always going to be positioned below the text box based on that attribute, right? And then you can specify margins. So how much space do I want there to be around the edges on the top, bottom, left, right? Yeah.
Yeah, do you know what the difference is between Android and app?
Android and app. That's a good question. Taylor, can you bail me out on this one? Do you know? What's the difference between this label here, Android, and this label here, app? Coming from two different sources? Okay. Okay. So they're just in different packages, essentially. The attributes are defined in two different packages. Sure. Okay. Thank you. And I don't know why they're categorized that way. I have no idea. There's probably a reason, but I don't know why. I don't know what that reason is. The attributes that are most important to us, though, are the ID, for sure. That's giving something a name. This is what allows us to refer to something in code as well, right? When we get to the coding part of things. So I can refer to this in code. But it also allows us to refer to it in other views so that I can do things like relative positioning. So having that label really makes life easier for us. Any questions about this before I move on to the next piece? So then in the activities and the fragments, that's where we specify the behavior of the user interface. Only things like navigation, only things like handling button presses, things like that. That's all we're worried about in activities and fragments. So if I pull up code for the main activity, for example, you can see that, and this is kind of what we had you looking at in Studio last week as well, it's really just making sure that I have the right fragment loaded. I had two fragments. I had one for when I had to select the category and the number of questions, right? That was one fragment. And then I had another fragment that displayed the actual trivia questions that were retrieved. So I had two different fragments, and this main activity is basically just tracking which one should be up at any given point in time and loading it using the fragment manager. So for those of you who have completed or got most of the way through the previous Studio, you're already kind of familiar with the fragment manager, but I'll talk about it briefly now, and I'm sure Taylor will talk about it more on Thursday when he goes through the Studios. The fragment manager can pull up any fragments that I have in my app, and then you see that it works kind of like a transaction. If you're familiar with database programming, this idea of a transaction kind of comes from there, where I specify any options that I want about my fragment. I specify where I want it to go. Where should this fragment actually live, right? And then once I've got everything set up the way that I want, I commit it, which is what actually makes the fragment display on the screen. This process is the same for loading basically any fragment that you want. Yeah.
So can you edit the XML through the column code during the app's runtime?
Can you edit the XML through the Kotlin code? So
what I'm thinking of is if you have them press a button, then it creates another random amount of buttons on the screen.
sure.
Does that get put into the XML, or does it?
So I mean, it's not going to be saved in the layout file, right? But I can dynamically change the view. Yes, that is possible. I can dynamically add stuff to the view, take stuff away from the view, change the properties of the existing elements that are on the screen. So in other words, you're manipulating, I'd hesitate to say that you're manipulating the XML. You're manipulating the layout. The XML, this is basically specifying the starting point of our layout. And then if I want to manipulate this configuration in my activities, I can, or in my fragments, I can. In fact, we have to, if we want to do things like load a new screen, we have to. That's how it works. I'm picking up a new fragment and then loading that into the spot where the old fragment was. And so every activity is going to have a Kotlin file associated with it. Remember, fragments live in activities. A fragment can't really stand alone by itself. An activity can, a fragment can't. So a fragment's typically going to be embedded within an activity. So the activity kind of plays like a fragment manager in a way. Loads up the various screens that I'm interested in. And then inside of the fragment code, if I pull up one of these, you'll see that what does it do? It creates the view. So it grabs the layout, the XML for the view that I want this fragment to display, and it inflates it, which basically means it creates all of the different UI pieces and situates them appropriately on the screen. That's not all, though. To understand activities and fragments, I know I talked about this last week, but I'm going to talk about it again real quick. We have to understand the life cycle of these particular components. So this is definitely a review, but let's talk about it anyway. When I start an activity, right, it fires off a few functions. The onCreate function when it gets created and the onStart function when it gets started up. And then once it's started, it's just running, and that's fine, and everything's going well. And then it can be paused or it can be stopped if I navigate away from a particular activity, and then restart it again once I come back. So anytime those things happen, anytime the user navigates away from the app and then comes back to the app, these functions are going to fire. And that's our main access point into our activities and into our fragments. There's a similar life cycle for our fragments as well, right? So we have to think, okay, what are the things that this fragment needs to do when it's first created, when it first starts? There are some very obvious things, like it needs to get its layout and construct all the pieces so that it can be shown to the user. That's almost always going to happen in the onCreate function of your activities and fragments. It's just going to grab the layout and set it up so that the user can see the UI for that particular fragment or activity. There might be some things that you need to do in these other functions. You'll notice I actually haven't used most of these yet, other than from a trivial demo that I did last week. The ones that I use the most are onCreate, maybe onStart for an activity, maybe onAttach for a fragment, which is when it gets associated with an activity, since fragments have to have an activity associated with them. Those are the main ones that you're going to use. But if you wanted to, so one might use some of these other ones, right? You could use onPause or onStop to unload some data when a user is navigating away, so that you're freeing up some memory space for other apps that are running. And then when they come back, you would just load that data up again, right, in the onStart function, perhaps. As one example, as one possible example. You might want to do some cleanup on destroy. If you're using files, you probably want to close them so that they're closed properly, right? Things like that in that particular function. So these are access points. These are the ways that our users will access our apps, but these are also how we as programmers think about people accessing our apps. And so that's why you see in our application, the first function that's going to be listed in an activity or in a fragment is going to be onCreation, typically with a call to the layout that you want to be displayed. Are there any questions about that? We'll start using more and more of those lifecycle functions as time goes on. I just wanted to highlight the major ones. So that's all UI stuff. We've actually just done all user interface stuff so far. We haven't done anything besides user interfaces. Let's talk about something else for a minute. Talked about layouts. All right. Remember, the architecture is called model, view, view model, which I know is just like some kind of weird palindrome thing. We talked about the view. The view is constructed with layouts, activities, and fragments, which manage the behavior of my user interface. The model is the data. The model is the data that your application needs to run. So this is new territory for us. We actually haven't had a model really for any of the apps that we've been working with up until now. The model is the data that your application needs to work with. So in my app, my trivia app, I have a couple of models. I have a model for the questions, and I have a model for the categories, actually, as well. Let me show you what the model code looks like in my app. Here it is. This is my question model. It's a very basic class. That's all there is to it. Models typically are not particularly complicated. It's a class that holds a set of properties that represent the different attributes of your model. It's meant to be a container for data. That's what your model is. It's a container that holds data. Models make things nice for us, though, because I can take those models and easily pass them around my app to where they need to go. Right? So here's, you can see the stuff for the questions. I've got another one for the categories, even more straightforward. There's only 2 properties that my category contains. So the more interesting part of the model then is, where does this data come from? And that's what we're going to be talking about over the next couple of weeks. Web APIs are one common place where the data actually comes from. So on Tuesday of next week, I'll show you this app again. I'll show you how we access an API online to grab information and then put it into these objects, these model objects, so that we can use the information in our app. And then the week after that, I'll show you how to use a database as a source for your model as well. But the model is the data. That's what the model is. And it's represented by classes, just plain old classes, Kotlin classes in your code. Now we need to bridge that gap between the model and the view. So the data is no good to me if I can't see it, right? I need to have a way of visualizing that data on my user interface. And this is where an adapter comes in. There's actually a paragraph or 2 on the homework 1 write-up about adapters. Yeah?
I don't mean to interrupt you. You have the model.
Yeah.
I don't typically have that folder. How did you create that?
Oh, okay. Good question. Good. Yeah, good question. I did make a model package. It's a package, just like a Java package. I right-clicked this package, which you probably do have something similar to this. I just right-clicked this and went to New, and then, well, where'd it go? Package, there it is. It's right under my nose. New package, and then give it a name. You don't have to do that. I actually think, though, it's very good to keep things organized, especially, you can already kind of see there's a lot of files going on here with these apps, right? So organization is something important to pay attention to as you're creating your apps. Great question. Yeah?
So you might have touched on this, but I missed it. So when the category is filled out, like we go grab a category and fill it up, where is that stored? So it's like, how do we access it? Right? Because in other programming languages like C++, it would be stored in a place that we made in the function. But different activities could access the same information.
Can different activities access the same information? Yes. Different activities can access the same information. We need to talk about view models, though, in order to discuss that particular piece, which I'm going to get to in just a minute. Great question. Yeah, I'm kind of dancing around where the data actually comes from because I want to talk about web APIs and databases over the next couple of weeks. But I do use these models in my So here you can see that this is a fragment. This is one of my fragments. You can see that I have an array list of questions. Those are the questions that are going to be displayed to the user via the UI. But back to this concept of adapters. This is, I think, is an important concept, especially because it's part of your homework 1 assignment. It provides a view. So an adapter serves two roles. It provides a view with access to the data items. So the UI needs to have access to the data in order to display it. But it also dictates how that data should be displayed. How do I actually want to display that data to the UI? Let me give you an example just to kind of illustrate why we need these adapters. I can actually show you in the code. So when I pull down the categories, regardless of how they get there, right? Regardless of how I pull down the categories, which I'll talk about at a later date, these two lines of code here, I end up with an array list of strings where those strings are simply the, actually I start with an array list of categories and I pull the category name out of those category objects, out of the model. But then I have an array list of strings, which represents the names of the categories. And I want to display those in the spinner, in the drop-down menu. But I need some way of mapping that information. I need some way of getting that array list of strings and passing it to the combo box. And so the way we do that is with an adapter. Now this is about as simple as it gets with adapters, because the data structure that I have is very straightforward. It's a list of strings. It's just a list of strings. So I create a new array adapter for strings, and I pass in that I want to turn them into spinner items. I want them to become part of the spinner, part of the combo box. And then I pass in the list of values that I want to be displayed in that combo box. And then once I have the adapter, I pass that to the actual combo box itself, which is what this second line does. So both of these two lines here are where the magic happens, right? Now, if I want to use something that's more complex than just a string, that's when we need to understand how adapters work in a little bit more detail. That's when I have some decisions to make. So I might have, for example, I might have like a user profile, right? And the user profile consists of an image, that user's picture, and maybe like the number of friends that they have, right, on the social network. So in my app, I could have a user model. It's just a class that contains properties for the image and for the number of users. But I need to have a way of translating that to the UI. And a plain old adapter like an array adapter is not going to cut it, because now I'm dealing with an object, a user object, not just a simple string or a simple int. I'm dealing with an actual object. So a custom adapter, you can customize your adapter. And what that lets you do is by extending the adapter class, you can then assign properties from the model, which is just your object, your class, to parts of the view. So I'm going to pull pieces from my layout by the ID and assign pieces of the model to those views from my layout. An adapter is really just a mapping, right? I have an object with a bunch of properties. I have an interface with a bunch of elements on it. How do I map the properties from this object to the elements that are on this interface? A custom adapter is the way to go. So the way we do that is we extend the adapter class and we override the getView method. There are a million examples of this online. I think I actually linked you to an example of this in the Homework 1 write-up if you're looking for more specific coding details. But just to recap, if you're doing something simple with strings or ints or some basic data type, you can use an adapter directly a lot of the time. If you're doing something more complex with your objects, model objects, chances are you're going to have to define a custom adapter. actually have a custom adapter in this app, but I wanted to talk about a couple of other things before I showed it to you. So we might get to it later. Are there any questions though about adapters and the role that they have? Bridging the gap between the model and the view. All right, piece number 3, the view model. Well, look at that. Also bridges the gap between the view and the model, but in a slightly different way. In a slightly different way. The view model, at the end of the day, is really in charge of retrieving the data necessary to create the models that you need in your application, and then exposing them to the view, the UI. So as the name implies, it kind of sits in between the view. In fact, if we look at the diagram, we can see that I showed at the beginning. This is my view up here. These are both technically actually all of this down here is technically my model, kind of, and the view model sits in between. So the view model is responsible for making sure data gets loaded properly into the models and then passing that up to the view to be displayed via an adapter. So my adapters actually lived in the view. The big advantage of using a view model, so consider what our apps might look like if I didn't have this third intermediate piece. I could, if I wanted to, write code in my activity or in my fragments that accesses a web API or accesses a database. I could do that. There's nothing stopping me from doing that. Then the data for my app lives directly in the activity. Directly in the activity. This is bad for a couple of reasons. One, consider what happens if that activity goes away. The data goes with it. The data's gone too, because I loaded the data directly into the activity. I didn't have a separate place for it. I just loaded it directly into the activity. So if the activity goes away for some reason, the data's all gone as well. It also does not do a good job of separation of concerns. It's bad coding practice. There's actually a name for apps that are designed in this way. We call those God objects because they're trying to do everything. Trying to manage the UI, trying to load the data, trying to put the data into the UI, do it all in one big file. Right? We've all been there. I'm not gonna lie, I've been there. It's happened. It's a bad idea. It makes messy code. It's not good design. A view model, besides the code design, helps us in another way. It keeps the data available. So if I'm running an app like Facebook, for example, I don't want it to dump all of my data just because I navigated to a different part of the app. I want it to keep that information around because I'm gonna need it. I'm gonna need it. So I'm gonna keep the data out of the activity because I'm gonna eventually navigate away from that activity. Don't keep the data in the activity, keep it in the view model, and then pass the view model from activity to activity so that your data is always accessible. It's always available to be used, regardless of which activity or fragment or whatever you are currently in. Does that make sense, I hope? Does that make sense? This is new as well. I understand that we haven't talked about this yet today, but it's a very important part of dealing with Android apps. And so I do have a view model. You'll notice I actually just have one view model, which is a little curious. I have two models, category and question, but I just have one view model, which is the question view model. Do I have time? I guess I have time to kind of explain why I did it that way. I wanted to illustrate both dealing with data with a view model and trying to deal with data without the view model is why. So I made a view model to handle my question data, and I'll go through what all this is doing. It's not a ton of code. I'll go through what all it's doing in just a little bit. Let's go through the opposite one first. The category does not have a view model, and actually we just looked at this code a few minutes ago about how it gets retrieved and loaded into the spinner box. So you can see actually the categories live directly in the fragment where they're being used. For this app, it's actually hard to see the negative side effects of doing it this way because I only use the categories in that one spot. But if I ever wanted to use the categories in various parts of my app, this would be a problem to have the categories loaded in the fragment like this and used directly in the fragment like this, because I have no way of accessing these categories outside of this fragment. So if I had another screen that needed access to that category information, I don't have a way of getting it. Not with this setup, because I don't have a view model. By adding in the view model, if we look at the other fragment that I have that uses the view model, the question list, it uses the view model right here. I'm going to grab the question view model, and I can run this line of code that accesses the question view model from any fragment, activity, whatever I want. So now I have a quick and easy way of accessing the question data through the view model. Does that make sense? I know there's a lot of other code going on here that I haven't explained yet. I'm getting to it. Does the view model piece make sense? Why it exists? Yeah. Yeah, sure. Let's take a look. So what is actually in the view model itself? This was actually, I don't know if it was next on my list to talk about, but it was pretty close. So let's talk about it anyway. I've got something in my view model called a live data. It's actually called a mutable live data. There's another object that's just called live data that's immutable. That's the only difference between the two. A live data object serves a very specific purpose. Consider what happens if I load up a bunch of data and then I navigate away from my app. I don't kill the app, I just switch to something else, right? Or I hit the home screen, I go back to the home screen. What happens to that data? Poof, gone. It gets cleared out. It gets cleared out. And so when I come back to the app, what happens? It sees, well, the data is gone. I have to reload it again. So if I got that data from a database, or maybe even worse, if I got that data from querying a server somewhere online, I now have to wait for that to execute again, even though I already did it and I already had the data before I paused app execution. So what a live data object does for me is it keeps a live copy of that data in memory so that when I navigate away from the app and come back, I no longer have to rerun that query. I no longer have to acquire that data again. It manages access to that for me on my behalf. And it's pretty simple to use. Excuse me. You can see that I keep a product list, which is really a live data object, but then within that live data object, I specify what data structure I want this live data object to represent. In this case, an array list of questions. So I have a live data object for an array list of questions. So what does that actually do? It allocates a chunk of space in memory for me to hold an array list of questions, right? And then I feed data into that object, which for us is just loading. Why does it say products? It should say questions. My fault. I'm going to change this now. Loads questions. And in this particular app, it loads the questions from a web API, but it could be from a database, it could be from a file on your phone, it could be from anywhere. Where the actual data comes from doesn't matter. Once it gets loaded into this live data object, it is now in memory. It's now not going to go away until the app has been completely closed and killed off. So I don't have to worry about running that over and over again. Very easy to use. The rest of the stuff that you see down here, actually this stuff on down from this product async task, that's what I want to talk to you about next Tuesday. So I'm not going to dive too much into that today. That's web API stuff. We'll talk about that next week. So really, you know, this stuff here is all part of the mutable live data object that keeps a live copy of that information in memory so we don't have to keep reloading it. Are there any questions about that? Again, it's not necessary to use a live data object. I can skip that part if I want, but I have to realize that the performance of my app is going to suffer as a result. Yeah?
Using mutable live data objects, people point to the web in them.
For a database, I can use it for files, I can use it for whatever I want. So any data in my app. It's tied to my models, right? So you'll notice, you see here, question, that's my model, right? So think of what models you have. How are those models, how am I going to keep those models around my app? Is it going to be a list of them? Is it going to be just maybe one, right? What is it going to be? I can create a live data object to represent any data structure, well, not any, most data structures within reason. I can create a live data object to wrap around that to keep that in memory so that my app has quick and easy access to it. Question?
Is there any kind of permanent storage for apps?
Permanent storage?
I guess super strict because something, if we want to store something even when the app closes.
Yeah. So we're going to talk about databases in 2 weeks. That's one way. Yeah. Yeah. Databases. You can also do files too, right? Which actually on phones, databases are files, really. Like there's not, but yeah, we'll talk about that for sure. Another very common way is actually what we're going to talk about next week, which is I can have a server with a database on it instead. I don't have to have the database on my phone. I can put the database somewhere else and then just make a request to access that. But again, it takes time. That's a request that's sent out over the internet. And also too, phones have a limited amount of data a lot of times. So if you use a bunch of data on your app, people are going to get angry at you, right? So that's why things like live data are considered to be important parts of apps. It saves on not just performance, but also on how much of your mobile data usage is going on in your app. And those are the kinds of things that we don't always have to think about when we're doing things on our computer, right? Worrying about data being in memory. It's a concern on your laptop, but it's not nearly as big of a concern as it would be on your phone. There's just less resources available. More restricted access to those resources. Great questions. Any other questions? Any other questions? Yeah, in the back. To the best of my knowledge, if you want to pass information from one session to the next, you got to stash it in a file somewhere. Is that right, Taylor? Is there another way that I'm not thinking of?
In a file is correct.
Yeah.
The databases, like you said, it's called shared preferences.
Okay. Yeah. It's going to be in a file one way or another. Yep. And we will talk about that in a couple weeks. Great questions. What other questions do you have? So the concept behind this live data object is important, right? It's something that's really uniquely suited to phones. And there's other things like that exist as well in the Android ecosystem to try and minimize the amount of times I have to fetch data or to try and increase the performance of data access. It's a really important concept. For the reasons that we discussed. And so I think I have another example of a piece of code that does that, which is the recycler view. The recycler view is really just a list view. So if I have a list of things that I want to display, I can use something called a list view. It does exactly what it sounds like. Displays a list of things to the user. I can also use what's called a recycler view, which is useful when I have very large data sets or data sets that I expect might be changing somewhat frequently. What a recycler view tries to do is, again, tries to hold items in memory as much as it possibly can so that they can be loaded quickly and so that if I navigate from the app for some reason, it doesn't get lost. So as an example, imagine a list with I load up an app and it's got a list of maybe 8 or 10 things on it, right? The recycler view is going to load up those 8 or 10 list items and keep them in memory. They're in things that are called view holders. The view holders, there's one view holder per item on my list. What it's also going to do is probably load up the next 2 items below the list as well, so that when I scroll down, I don't have to wait for another request to go through to pull that data in. It's already there. It's already loaded. And as I scroll down, it's gonna keep trying to stay ahead of me with the view holders, so that I don't have to wait for a database query or an API query to go through when I scroll through a very large list of items. It's gonna try and keep those tracked in memory. If I scroll too far away from something, right, I'm all the way down at the bottom of the list, it might start freeing items at the top of the list so that memory doesn't become too globbed up. And so it's just going to keep swapping things in and out of memory on my behalf. This is another convenience. I know it sounds like extra complexity, and in a way it is, but it's actually a convenience. We used to, Android app developers used to have to do this manually. They used to have to create their own objects to do this for them. So Recycler View really simplifies the process. And that's what I use with the question view model in this particular app. So we can take a look at that as well. That's going to be in my question list. So on create view, right? I load up the layout. And then here is where the recycler view stuff starts to come into play, I believe. Sorry, the text is too big, and I wish I could see more code. Let me see if I can do that real quick. All right. Let's take a look at the view holder, which is down here. Well, here's an adapter. We've talked about adapters. So what is this? This is a custom adapter to take a question and map it to my recycler view, specifically the view holder, since that's what a recycler view wants, is view holders. So what does this custom adapter do? It grabs elements from my questions. This is a question object, or it's a view holder object, more specifically. And it says, I want the value from my question object to be mapped to the text, to the text element from my view holder, which the view holder is just a layout. Actually, I skipped that very important step. Let's look at the layout first. Sorry, I know I'm kind of bouncing around. I promise I will bring it all back here soon. This is the view holder. This is what I want. This is a layout that represents one question. How do I display one question? That's what a view holder is. How do I display one question, one element from my list? So I've got a text view for the prompt, the actual question, and a text view for the choices, the multiple choices that could be the answers. And so then going back to the code, where did that file go? Here it is. Going back to the code, text here refers to that text view from the view holder layout that I was just showing you a second ago. Or I'm sorry, prompt and choices refer to those text views that I was just showing you in the layout a few seconds ago. So I'm mapping properties from my object. This is a question object. I'm mapping properties from my object to the UI elements of the view holder. And then the recycler view will take in a whole bunch of these question view holders. Actually, the actual question view holder itself is defined here. It's just got two elements, the text views, the two text views. The recycler view then deals with those question view holders, one per question item, and displays them for me based on this binding that I created in on bind view holder. And so I actually pass the questions in well, here's the adapter that I pass in. And so another thing that's worth mentioning about these recyclable views is that they can also watch your data and sense changes, detect changes in the data, and automatically update the view based on those changes. And the way that it does that is with an observer, which is what we see here. We attach an observer to the data set, and then it's going to use these methods to see, are these items the same? What's the size of the list, right? So if any of those values change, if the list size changes, or if it goes through and detects that the items are no longer the same, it will update the UI with the new data that it has detected. So really, this recycler view is doing a lot for us. This is recycler view is covered in the previous. Is it covered in the previous studio? I think it is. Is it covered in Studio 1 or Studio 2? Might be Studio 2 that we'll do next week. But anyway, what questions do you have? We're almost out of time. And I'll be honest with you, I know I didn't do the recycler view complete justice because I sort of ran out of time. But what questions do you have? Yeah.
Yeah, if you scroll down,
Yeah.
I think it's near the bottom.
The very bottom?
Or actually, yeah, just like right there, where where you do with the prompt. Yeah, so it looks like, so I see some P0 is a parameter, and then it assigns like P0.prompt.text.
Yeah.
Like passes, so is P0 like a reference?
Oh, great question. So let's visualize this a little bit. Let me draw a diagram. I think it'll help. I have a list of questions, right? So here's my questions. And this is just an array list of question objects, right? Objects. But then I also have a view, I also have a list on my layout. How I actually see those items appear on the UI, that's also a list. That's the recycle view. And so what's that a list of? It's actually not a list of questions, it's a list of view holders, UI elements. So I have a second list over here. Where these are view holders. And so this method, which is really, I think, sort of the whole meat of the recycle view setup, says, all right, I have this view holder, that's the first parameter, is one of the view holders from the list. I want to map this view holder to element number whatever, P1, right? That's the index into my objects. So I'm going to take the object at index P1 and map it to the view holder. Those are my two parameters coming in here. So how do I do that? I pull properties from my object. You can see that's what's going on here. I use P1 as an index into my list of questions to pull out the object, and then I pull out properties from my model. And I tack those onto UI elements of my view holder. In this case, prompt is a text view. So I'm just taking the text out of the Kotlin object and putting it into a text view, which is a UI object, mapping between the data and the UI. Does that answer your question?
Yeah, I think so. So it's just so it's like so P0 isn't being passed by value.
It's all references all the way down. Yeah, just like Java is all references all day. Kotlin, I believe, is the same. It's all references. Yep. This question view holder, though, I defined, right? And so how does it work? It grabs the actual text view objects from the UI So what is a view holder? It's just a collection of UI elements encapsulated in an object. And then I map my objects to that UI element in the binding method. We'll see recycle views come up a lot more often, so this is not the last time we're going to see them. I understand it's a relatively complicated concept. I understand this is the first time we're talking about it, so it might still be a little fuzzy for some of you. Be patient. We'll talk about it. It'll get easier as time goes on. I hope today was helpful, going over the app structure, going over the app architecture. I am out of time, but I actually covered everything that I wanted to talk to you about. If you're still confused about some things that you've seen in class exercises or the studios or whatever, please let us know. Taylor's got office hours tonight. He's going to be running a studio review on Thursday, so bring studio questions on Thursday, especially if you haven't completed the studios. Bring studio questions on Thursday so that you can ask Taylor about those, and keep providing us feedback. Today happened because of feedback you provided. I hope it was helpful to you. Keep providing us that feedback. We want to make this course a good experience for you. So
survey, right?
there were 2, but that's okay. 1 for Studio 0, 1 for Studio 1. Every studio has a link to a survey at the top. Yeah, that's all right. Thanks, everybody. See you on Thursday.